Now come to the visualization part here. Okay, we will draw a plot which will show the row demand over the time, and we will consider our demand column for this purpose. And dot plot. Here we will set the size of our figure using the fixed size function, and I am setting it as 15 by 6, and we can also give the title to our plot, and let's choose the title electricity demand over time and plt dot show. So the command is running here and it is the output. It is showing electricity demand over the time from the year 2020 till the year end of 2024. Okay, means December 24. And here we have the maximum demand, and you can notice here about 10,000 megawatt. Let's give the naming to the x-axis and y-axis. The naming given to x-axis is year, and the naming given to y-axis is demand in megawatt. After running this is our output. It is year and it is demand in megawatts. Here if you see, at the starting month of the 2020 means January, February, March, it is cold, so the demand is less, and as the time or month goes, the demand increases, because in summers the demand increases everywhere, and similarly it goes down in winter again and it goes up, and in winter the demand is low and in summer the demand is high in each year. Now we will visualize the demand by hour of the day. For this we will create a box plot here. So first of all, using the Matplotlib library, I will set the size of the figure. Now using the Seaborn library SNS, we will draw a box plot, and here first parameter we have data. This is our parameter name and this is our actual data frame name. Okay, so don't confuse with it. And we will have our next parameter x-axis. On x-axis what we want our here. Next we have on y-axis we want demand. Okay, so this is our box plot, and we can give the title to this box plot, and I am mentioning the title here, demand by hour of the day. Okay. Now we can use the plt.show, or we can simply put a semicolon at the end of this command, and after running this it is our box plot, and it is showing demand by hour of the day starting from 0 till 23, and it is the demand on y-axis from 2000 to 10,000 megawatt. In a box plot, this upper T represents the maximum value, while this lower T represents the minimum value for each hour. Okay, and this strong line represents the median, and this line represents Q1, or you can say quartile 1, means 25% values of the all values are below this value, and this upper line, this one, represent Q3, means the 25 values of all the values falls above this particular Q3 value, and these points you can see here are the outliers. Okay, so after seeing this graph, we notice that at 7 p.m. which is 19, we have the maximum demand, okay, from here, and it is about 9,000 megawatt. Okay, and minimum demand is present at 3 a.m. in the morning, which is about you can say 1800 megawatt. So that's how we can read the box plot. Similarly, using the box plot, we can visualize the demand by month. So again, use the Matplotlib library to set the figure. Then we will use the Seaborn library to draw the box plot, sns.boxplot, and we have to give our data first of all our data is stored in variable data, so I am passing here. Next we want the x-axis. On x-axis we want month this time, and on y-axis we want demand only. And we can rename the plot plt.title demand by month. Okay, at last plt.show. So this is the demand by month, and it is showing the months from 1st to 12th, January to December, and this is the demand on y-axis. And this one point is our outlier, and we notice here that in the month of July, or the 7th month, we have the maximum demand, which is reaching above 10,000, while in the month of December here, or you can say in month of January, we have the least demand. And these are the minimum and maximum demand per month, and this is the median. Next we can draw a scatter plot representing the demand versus temperature using the figure function, setting the figure size 10 by 6, and we will use the Seaborn library and scatter plot. In this plot, our first parameter is data. Here the second parameter is on x-axis. On x-axis we want to show the temperature. On y-axis we want to show the demand. Here I can use one more parameter, which is alpha. Alpha is used to set the transparency of the points. Okay, so and its value is from 0 to 1. Okay, so I can set a medium value, suppose 0.5. Then we can use the title for this plot also. Here we can give demand versus temperature. At last plt.show. Running this, it will show the demand versus temperature in the form of a scatter plot. As you can see, as the temperature is increasing, the demand is also increasing, and it is obvious because in summer or in high temperature we use more AC, more cooler, more fan. Okay, and these points are the outliers. When the temperature is about 10 degrees Celsius or below 10 degree, the demand is about 2000 megawatt only, and when the temperature is 30 degrees Celsius, the demand is also increasing, and it is increasing from 3000 to about 6500, and we have the maximum demand here at 50 degrees Celsius of about 8200 megawatt. Next we will draw a correlation matrix to show the correlation between different numerical features of this dataset, and the correlation matrix is used for understanding the linear relationship between the different features of a data frame. So let's see. First of all, we have to consider our data frame data, and this CORR function means correlation is used to draw a correlation matrix. When we will run this, it will show the output like this in the form of a data frame, you can say, and we can draw a heat map also for this correlation. And first of all, we will set the figure size for the heat map. So I have set the size of the figure as 12 by 8, and now using the Seaborn library we will draw a heat map for this correlation matrix heat map. Our first parameter in the heat map will be our correlation matrix, this one. Okay, I am removing this from here now, and we want to also show these numbers in our heat map, so I can use a parameter annotate equal to true. When we will run this, this is the heat map for the correlation matrix. We can make it more readable by reducing these decimal points using the parameter fmt. I am setting it to 2 decimal points, so I can write 0.2f like this. Okay, and plt.show. Now it will look like this. Here 0.2f means you can see after the decimal it is showing the value till 2 points only, and annotate true means it is showing these numeric numbers in this heat map. Okay, now I can set the title for this matrix heat map and plt.title. Here I have set the title as correlation matrix of features. So after running this is our title. Now try to understand this correlation matrix. Here we have our main target variable, which is demand. We have to check the correlation of this column demand with our other columns. The range of the correlation matrix lies between -1 to 1, and if there is 1 means the two features are positively correlated. If the value of one column increases, then automatically the value of second column increases, and if the correlation matrix the value is -1 means the two features are inversely correlated. If value of one feature increase, then the value of second column will decrease. If we check this demand column, it is showing 0.04, means this demand column is, you can say, highly correlated with this hour column. By this correlation of demand and hour column, we can conclude that the demand is highly depending on the hour of the day. Next, if we consider this demand column with the temperature, it is showing 0.83, which is near about 1, means the demand is also correlated positively with the temperature column. As the temperature increases, the demand will also increase. Here also the demand lag 24 hours, and these are the correlation, and it is also negatively correlated with is weekend column and day of the week column. The diagonal of a correlation matrix always show a value of 1. Now this visualization part of this project is also completed, so we can move forward to build our prediction model.